class. In previous lecture, we were in chapter 3, risk and return. So today we continue where we stopped last time. Okay, so now you know how to calculate covariance and the meaning of covariance. But please note that the covariance can be negative and positive. Yeah, it measures whether both variables tend to be high or low at the same time. So a positive covariance means the two variables they move in the same direction and vice versa. A negative covariance means the two variables move in opposite direction. But covariance doesn't tell us to what extent that the two assets move together. I mean the level of moving together. Okay, if one asset move, for example, if one asset increased 10%, whether the second asset also increased 10% or increase only 2%, right? Or for one asset increase 10%, whether the other assets have negative covariance means they move in opposite direction. And so if one asset move increase 10% and the other assets decrease, for example, 10% or decrease about 5%. Yeah. So covariance doesn't tell us the extent to which the two financial assets move together. Yeah. So we use another concept in another method to measure not only the direction, but also the extent to which the two assets move together. That is correlation. Yeah, and we call them rho. And how to measure correlation? You see, we take the covariance of the two assets I and J, and we divide it for the product of standard deviation of I and J. Yeah, and by by dividing something, the price, the return, when you divide something with its standard deviation. In finance, we call that action is standardized. Standardize mình chuẩn hóa các bạn ha. So that is a financial technique that you use to deal with assets from different units. Yeah, they have different units or different currency. Yeah, so you want to standardize them, so you divide them for the standard deviation. Then you get the standardized number. Yeah, so in this case, we standardize the covariance of assets ing and we get correlation. So correlation can be correlation. The value of correlation is only between 1 and -1. So this one, yeah, it can be -1 and 1. Yeah, you see the bracket. The bracket means it can be equal to -1 or 1. Yeah, and correlation never out of this range. Okay. Okay, when the correlation is equal to 1, we say the two assets are perfectly correlated, or the two assets have perfect positive correlation, tương quan dương hoàn hảo. And when the rho is negative, then we say the two financial assets have a perfect negative correlation. Yeah, in reality, we hardly find two financial assets, two distinguished financial assets will have perfect correlation, either negative or positive. So usually it's range between -1 and 1. Okay, and the higher the rho, yeah, the absolute value of the rho, the higher relationship. The higher extent to which the two financial assets move together, either in the same direction or in the opposite direction. Yeah. So when rho is 0, what does that mean? It means the two financial assets have no correlation. No correlation. Okay? And okay, so usually when rho is rho usually when you say a rho of some financial assets larger than 0.5 or rho smaller than negative 0.5, we may think that the two financial assets have strong correlation. But be caution. Yeah. Note that the correlation of two financial assets doesn't mean that two financial assets have relationship. Okay? I will give you one example. One example, if you take, the growth rate of your height, yeah, and you compare with the growth rate of your neighbor's friend, yeah, you two grow up, together and being taught together. And if you compare the two growth rate, you see, you take the correlation, you see they are quite high correlation in the growth rate of your eye. Yeah? But actually, the question is whether you have any relationship. No, you don't have. Because you two are independent, but you follow the trend. Yeah, you grow up and shoulder your neighbor. Yeah, but if you have a relationship, no. So be careful. Okay. Okay, and now I can rewrite the formula, this formula, and using correlation. Yeah. Okay, so now covariance ij equal to rho ij and multiply for sigma I and sigma j. Yeah, I replay this one to this position. Yeah, and I have the variance of portfolio. Yeah, okay. The two formula are the same, huh? Okay, now we are going to practice. Yeah, we assume that we have a portfolio of two financial assets, and then we compute the expected return of the portfolio and the expected variance or standard deviation of that portfolio. And remember, we have this exercise, we have this Excel exercise. Now I would like you to calculate the covariance and the correlation for each pair of assets. Okay, so we have basically we have three assets. So we have how many pairs? Three pairs. Yeah. So you calculate covariance for index and GMREP and MPP, and then index for MPP. Covariance and correlation of three pairs. Okay. And please do it at home using the formula. Okay. Here, you can check what I did here and compare your result with this slide. Okay, for example, I take out the pair GMDEP and MPP. Yeah, so in this example, the mean return of GMDEP is 9.1, MPP is 9.6%, and the variance of okay, here we don't have, in this slide, I don't calculate the standard deviation. We have the variance, yeah? Okay, here, 9.1. So GMADEP and MPP, yeah? The expected return and the standard deviation of the return, 9.1%, 9.6%. And this one is 15% of standard deviation and 11.41 standard deviation. Okay, so now we assume that we combine the two stock into one portfolio and see what happened. Okay, the first column is the weight of GMDAP. So you see the way I run from 0% of GMDAP to 100% of GMDAP. And the second column is the weight of MBB. So of course, in the first round, if the portfolio GMDAP is 0%, so 100% is from MBB. Yeah. So your portfolio is the combination between 0% of GMDAP and 100% of MBB. So I would like to call this portfolio is A and this B, C, D, E. Yeah. Okay, and now I compute the expected return of, portfolio. For example, we take portfolio B. Yeah. So the expected return of portfolio B, yeah. How you do? Can you do it? Yes, so please do it. Yeah. So this is the expected return of portfolio B that comprise from 25% of GMDAP and 75% of MBB. It's 9.48%. And please do it for the rest of the portfolios. Okay, now I calculate the variance. Yeah, variance. Again, I calculate the variance of portfolio B. Okay, notice that this one is the standard deviation. Yeah, standard deviation. So I have to make it square. And we had the correlation 0.51. Okay. Yes. And this equal to 1.2%. Yeah. And then I take the standard TDEV of portfolio B, that is the square root of 1.2%. And I get this number, 11%. Yeah, so please do the same for other portfolio A, C, D, E. Okay? Okay, so look at this. Look at our result. The portfolio with the highest, with the smallest profit is this portfolio E. Yeah, 9.1%. And this portfolio corresponds to 100% of GMDAP. Yeah, and that makes sense, right? Because look at this. GMDAP is, the expected return is 9.1%, and MPP had higher expected return. Yeah, so the lowest return, the portfolio with lowest returns is the portfolio of 100% GMDAP. And then look at the portfolio with the high return. That is the portfolio A with 100% of MBB. Okay,